All right, welcome back. Today we're going to be talking about number series. We did sequences last time. Today we're going to talk about series, a little bit different, a little bit the same. We're going to be talking about adding all those series, that sequence up and getting a sum for the whole thing. This is Mr. Kelly. If you didn't know, this is not a goatee. This is a go tree. He tried to shave his goatee into a tree. Mr. Kelly, if you don't know him, he is the king of puns. And he would tell me right now, when we're talking about series, he would say, "Are you serious, us? Just a pun master." And so we're going to pay a little bit of an ode to the pun master, Mr. Kelly, today. But before we get into that, I want to talk to you about a very famous mathematician. His name was Carl Friedrich Gauss, and if you study in Germany, he's from the area. He became one of the best mathematicians. But he was kind of a smart aleck, and he was often really bored in class. So one day, as a legend goes, his teacher, who wanted to keep him busy, came up and said, little Freddie Gauss is, bothering the teacher. And so the teacher says, "Hey, go back, sit, and add all the numbers from 1 to 100. Now, it may take you a while to do that. It may take me a while to do that. We're talking about an 8-year-old kid here, 10-year-old kid. It's going to take an 8-year-old a long, long time to add all the numbers from 1 to 100. So what I want you to do, pause the video. And I don't even care if you use your calculator. I want you to see if you can beat Gauss, all right? So right now, pause the video and see how long it takes for you to count from 1 to 100 in your head. All right, welcome back. So how long did it take you? It took me quite a while, I'm going to be honest. Even if you use a calculator, I'm going to bet it took you a lot longer than it took Gauss. It took Gauss all of about 10 seconds. Probably less. But let's talk about how he did it, because he kind of cheated, all right? He didn't just add the numbers up like we would traditionally add these numbers up. He didn't do 1 plus 2 is 3, 3 plus 3. So I'm going to use a simpler problem. Here's what Gauss did. He noticed that 1 plus 8 is 9. And 2 plus 7 is also 9. And 3 plus 6 is 9. And 4 plus 5 is 9. He noticed in his head this, which is incredible, right? So now instead of doing all this stuff, he could use this and he multiplied these numbers together to make his life so much easier. So he had 4 pairs of 9s that he had to get. All right? Well, he did 4 pairs of, 1 in 100. He had 4 pairs, or not 4 pairs, but he had a sum total of 101. And how many pairs did he have? Well, if there's 100 numbers, right, he would have had 50 pairs, okay? Half of that. So let's take a look at this a little bit. How did he get this? Well, he had his first number and his last number. Well, the first number, we kind of know how to talk about this already. We've talked about in the past, remember our old formula? We could find any number in our sequence if it was arithmetic by doing the following. Our first term plus d times n minus 1, and d was our common difference, right? So let's talk about this. So he took his first term, 1 in this case, and what did he add? He added his last one, all right? Now he noticed that all these were going to be the same, but he could find out what the last number was, and we can do this as well. We know what the last number is going to be, right? So we could use this right here to find our last number, couldn't we? So we're going to add a plus d times n minus 1. So this is his first one, and this is his last one. And he adds those together. Let's see. If we use a little algebra, we have 2a's plus our common difference times d, or times n minus 1. So he added those together, and then he multiplied. Well, he multiplied by 4. How many pairs were there? There were 4, but how many numbers did he have? He had 8 here, so he did half of the 8. So if we have a certain number we don't know, we could do half of it, and voila, all of a sudden now, we have what Gauss did in his head as an 8-year-old boy for a formula. So let's talk about it. This is the sum of an arithmetic sequence. So arithmetic means what? It means we're adding and we have a common difference each time, right? So the sum for the arithmetic series is the number of terms, n, divided by 2, and we saw that. Those are the pairs. There's that many pairs. 2 times our first term plus our common difference times n minus 1. All right? So write that down real quick, and while you do, let's hear from the pun master himself, Mr. Kelly. Where did the killer whale play his musical instrument? Where did the killer whale play his musical instrument? And you know, if you have him in class, he definitely does this all the time. Well, he played it in the orchestra. Get it? Terrible. Just absolutely terrible. But we love you, Mr. Kelly. All right, let's try one. So find the sum of the first 30 terms. Ooh, that's a lot. All right, so here we go. So the first thing I need to do, let's see. Our initial term, A, is 4. Our common difference, 4 plus 6 plus 6 plus 6. So our common difference is 6. So let's put these in here. The number of terms we want to find is 30 over 2. 2 times our initial, 4 times 2 is 8, right? So this is 4. Our common difference is 6. N again now is 30 minus 1. All right? So we can do some math here. This is 15. This is going to be 8 plus. So this is 30 minus 1, which is 29. And 29 times 6 is 174, I believe. 174 plus 8 is 182. So we got 15 times 182. So for the first 30 terms, the sum of the first 30 terms is going to be 15 times 182, or 2,730. Whew. Holy smokes, that's a lot, right? All right. Now this is going backwards. How many terms until the sum of the series is 10,860? So we don't know that it's 30 anymore, okay? It's definitely not going to be 30, because in 30 terms, it's 2,700. It's going to be much more than 30, isn't it? You know, take a guess. What do you think it's going to be? You know, 40? Maybe? I mean, well, no. 40, you know, it looks like it's got to be much bigger than that. I don't know. If I doubled this, let's take a look. So here we go. So our sum, we actually know our sum now. Our sum is 10,860. So 10,860 equals, I don't know my n, divide by 2. Still doing twice our first term. Our first term, as you remember, was 4, so this is still 8. Our common difference is still 6. I don't know my n, so it's n minus 1. Okay, so I like to get rid of fractions. So I'm going to multiply both sides by 2. And the reason I want to do that is I want to get rid of this right here. So now I'm going to multiply this side by 2, and I get, well, let's see here, 21,720 on this side. And over here I have now n, and what's left in here? Let's distribute 6n minus 6. 21,720 equals n times 8 minus 6. So I have 6n minus, or plus 2, excuse me. And distribute again. So now I have 6n squared plus 2n. And I'm going to bring this over here. I'm going to subtract this. So I'm going to have 0 equals 6n squared plus 2n minus 21,720. All right. Now, in your mathematical career, you have learned many, many ways to solve quadratics. We could factor. How many of you know factors that multiply to 6 times 21,720 and add to 2? Not me. I don't know that one. We could use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. We could do that. That is a pain in the patootie. All right? I know this is going to equal 0, and here's a great thing about this one. We know that these term numbers are what? This is term number 1. This is term number 2, term number 3, term number 4. Do I have any decimals here? No. No decimals. Do I have any fractions? No, no fractions. Do I have any negatives? No negatives. I only am looking for positive numbers. All right? So I'm going to show you a trick that you can use to solve this, and it works great for this method. All right? This is a great method because these are big numbers, and I want to find out when it equals 0. When does y equal 0? that is a positive whole number. So here's what we're going to do. We're going to go to our graphing calculator. I know some of you guys just love the graphing calculator. All right, and what I did is I went to y equals up here, and I typed in my function. Now I used x's, 6x squared plus 2x minus 21,720. I'll give you a second to put that in. Now, here's what we're going to do. We're going to go to the table. To get to anything in blue, I have to press second. So I'm going to do second, table. All right, now this is 0. Do I need any negative numbers? No, because my term numbers are all positive. So what I'm looking for is when y equals 0. So here's y. So this is a big number. So I'm just going to kind of hold my button down here. I'm waiting for y to equal 0. All right. So y, boom, keep going. Getting smaller, getting smaller, getting smaller. Whoa, passed it. Right there. 60, 0. So now I know that the 60th term is my answer for when the sum is 10,860. So how many terms are there? N equals 60. Nice. All right, let's take a look at the next one. Mr. Bruss sends an email out to everyone he knows. So he sends the email to 12 people. Oh, Mr. Bruss. On day 2, each recipient sends that email to 4 different people. So let's see here. Day 1, 12 people. Day 2, each of these times 12, so that's going to be 40. 12 times 4, 48. This is, now I know right now, this is geometric, isn't it? My common ratio is going to be 4. My initial value A is going to be 12. How many emails will be sent out on day 7? Well, we know how to figure that one out, right? So the value of the function, remember, is our initial term times our rate to the n minus 1. So we can do this one. So this is going to be our initial term of 12 times our rate 4 to the n minus 1. So 7 minus 1 to the 6th. And if you plug that in there, I believe it's going to be 49,152 people on day 7. You got to remember, when we start multiplying, those numbers get out of control really, really quickly. It's one of those great things. Now, I could add these up. Day 1 I have, day 2 I have 48. Day 7 I know there's 49,152. I could find each term and add them up, couldn't I? How many total emails? That seems like a great, great waste of time. And there must be a better way. Let's take a look. And there is. So the sum of a geometric series, this is the formula for the sum of a geometric series. We take our initial value. We do 1 minus r to the n. So 1 minus r common ratio to the n, notice not the n minus 1, divided by 1 minus r. All right? So let's see if we can do that. All right, let's take this formula here. All right, copy it, and let's go back here. Let's see if we can figure this one out. So we have, I'm going to do it right here. So our sum of our first 7 days is going to be our initial value, 12 people, times 1 minus our common ratio, 4, n, 7, all of that over 1 minus 4. All right, now, you guys love putting things in your calculator all at once. And that's great. If you're good at that, more power to you. But most of you are just flat out not good at that. So here's what I would do. I work inside out. I'm going to do my top first. I'm going to do 1 minus 4 to the 7th. I'm going to press enter. All right. Now I can do this bottom by myself. That is 1 minus 4 is negative 3. So I'm going to divide by, see, it takes my answer, negative 3, enter, and I'm going to multiply it by 12. So the sum is 65,532. So the sum for the first 7 days, 65,532. 65,532. Very nice. All right, I think it's about time we have another pun. Why does Snoop Dogg always carry an umbrella? Very serious, Mr. Kelly. Here he is. Break it down. Faux drizzle. Swear he told this one today in class. Crickets. Just crickets. Awful. And I don't think Snoop liked it. All right, Mr. Kelly? I don't think Snoop liked it. All right, let's take this formula out for a ride. Here we go. Find the sum of the first 10 terms. So the sum of the first 10 terms is the initial term, 4, times 1 minus my common ratio. In this case, I'm multiplying by 3 every time to the n power over 1 minus 3. All right. So we have 4 times, we know n is 10. Sorry. So I have 1 minus 3 to the 10th over negative 2. Again, I would do this. 1 minus 3 to the 10th, divide by negative 2. I got 4 times 29,524. And then I multiply those together, and the sum of my first 10 terms is going to be 118,096. But what if we had to go backwards and I don't know what term it is? I just know the sum. Plug the sum in. I know my initial term still is 4. I know my rate is still 3. I don't know my term number. I still know that 1 minus 3 is negative 2. So here we go. The opposite of multiply by 4, I'm going to divide both sides by 4. And we get 3,280 equals 1 minus 3 to the n over negative 2. Multiply by negative 2, and we get negative 6,560 equals 1 minus 3 to the n. Scroll up a little bit here. Subtract 1 from both sides. That's negative 6,561. Divide by negative 1 makes us what's positive. Now I want to get the log. I'm going to use my logs here. Log base 3 of 6,561 is the same as log base 3 of 3 to the n. We know these cancel. So now I have n equals log base 3 of 6,561 is 8. There you have it. Very nice. I'd like you to try this one. So pause the video, try this one all on your own. All right, so let's take a look here. The sum of the first 9 terms. I put my initial term times 1 minus the rate of 5, my common ratio, to the 9th power over 1 minus 5. 1 minus 5 to the 9th I divided by negative 4. Multiply that number by negative 2, and my sum of the first 9 terms was negative 976,562. Down here, let's reverse it. So we know our sum is negative 39,062 times our initial value, all right? First thing I did was I divided that initial value over here, and I got 19,531. Then I multiplied by 1 minus 5, negative 4 on both sides. I got negative 78,124. I subtracted 1, divided by the negative, and then I took the log of both sides. Log base 5 of both sides, and I got my answer, 7. So the first 7 terms add up to negative 39,062. Very cool. All right, let's take a look here. Mr. Bean is on a mission to solve as many math problems in a week as possible. Of course he is. Why wouldn't he be? All right, the first day he solves 400 problems. That's our A. A is 400, right? The next day he solves 340 problems, and the next day 280. This goes down 60, and so does this. That means this is not geometric. This is arithmetic, so my common difference is 60, but it's going down, so I'm going to put a negative there. All right, if this pattern continues Monday to Sunday, how many problems will he have solved on Friday? So this isn't a total. It's not saying solved total by Friday, just on Friday. Well, we know how to find that. We're going to do the value of the function. All right, remember, and it's of n equals our first term plus our common difference times n minus 1. So we want, let's see, Monday, 2, 3, we want the 5th day. So here we go. So the value of the 5th day would be the first one, 400, plus negative 60 times 5 minus 1, 4. And I trust that you can do this one, and you get 160. So on Friday, he was going to do 160 problems just on Friday. Okay? All right. Let's see here. How many total problems will we have by the end of the week? Well, the end of the week, that's 7 days. So we need to figure out, we need the sum. So the sum of 7 days is going to be, let's see, let's write it down. N over 2 times, what do we got here? Our initial term, we got to do 2 times our initial term, right? Plus, we have to do our initial, our common difference times n minus 1. All right, so let's see here. N is 7, so this is going to be 7 over 2. And then 2 times our initial. Our initial was 400, so this is 800 plus negative 60 times n minus 1. 7 minus 1 is 6. Okay? 800 plus negative 6 times 6 is going to be 7 halves times 440. 440. And if you get that, you would see that by the end of the week, he would have solved 3,300 total problems. All right, there you have it. So if you have any questions, please let us know. Remember, it's more important to be nice. No, that's not my thing. Be the change you want to see in the world. Shout out to Mr. Kelly. Thanks for letting us have a little fun with you. If you're in his class, ask him for a pun of the day. Till next time, peace.